you're given the sum of two double integrals from 0 to 1, and yes. So our goal is to evaluate this integral, and you can see if you're gonna do computation right away here, you have two integrals. So professor recommend actually gave you a hint like change the order, and when you will change the order, you're supposed to get one integral. Okay. So you can see the first problem is going to be based on changing the order. So you want to make sure that you know how to do this type of integral. So let's do this problem together. Okay, so let's double check. So the first step, what we need to do, we need to find the domain of integration for both of these integrals. So we're gonna do this in xy coordinates because you have the dy and dx. So in this case, we can see that x changes from 0 to 1 and x changes from 1 to 2. So it means your region is going to be separated into two of these regions, yes? And then if you have dy, it means you need to imagine like that you have an arrow that you shoot in positive y direction. And then you can see for this region, what function is going to be intersected first? If you shoot like in positive y direction. Y equals to what?
Sorry.
Y equals to 1. Do you see why? Thumbs up, you got this? Okay. So it means for this one, you have this arrow, so you first intersect these regions. And then what you intersect? Y equals 8. So you intersect something y equals 8. So this is 8, this is 1. Thumbs up if you got the same. Okay. And then for the next one, I have x changes from 1 to 2. And what I have over here, I have this my y equals to y cubed and y equals to 8. Yes? Okay, so when y equals to x cubed, it means if I have x equals to 1, y equals to 1. So my x cubed starts here. Do you remember how x cubed graph looks like? Yeah, it looks like this. So in this case, x cubed graph looks like this. And we can see that when x equals to 2, then my y equals x cubed, it equals y equals 2 cubed equals 8. So I'm exactly going to intersect in this point. So this is now going to be second part of my region. Thumbs up, you got this? Okay. So any questions about this? Yeah. So what do you need to do right now? Yeah. So what you should write next, like equal. Every time when you write integral, you need to write double integral. So here I change my order. I'm going to put dx dy. Do you need to put any Jacobian here? When do you need to put Jacobian?
You actually change the variables.
When I'm changing the variables. I don't change here anything. Yes. Do you need to change my function? No. And I believe this is e to the x times y minus 3 cubed, yes? Does the problem says? Yeah, times? Or to the power? Times, okay. And then let's find my limits of integration. So that's my bounds for y. From 1 to 8, yes. What are my bounds for x? So what do we need to do? We need to shoot an arrow in positive x direction. So what's the first function do we intersect?
0.
0, okay. And then how we should express this function? So what is the equation of this function? Y equals x cubed. And then if I want to plug in here an equation, this equation should be in what variable? In y, yes. Because I'm entering dx dy, so it should be in y. So what do I need to do with this equation? I need to find the cube root of the both sides. So from here we'll get that x equals cube root of y. And this is exactly what you're gonna put here, cube root of y. And we have the same function, e to the x, y minus third. Yes? Thumbs up, you got it? Okay. What is the fastest way to evaluate this integral? There are two ways how we can do it, step by step, or we can just split them. Yeah. So if you're like, okay, so if you don't feel comfortable without doing any kind of this trick, don't do them. Just do like as you know problem. But if you remember that your function can be like separated into multiplication of function in terms of x and in terms of y, you can just split your integral. Yes. So in this case, what I will get? I will get the integral. But it's like no, this one we cannot split. This one we cannot split. Why?
The function is x. What? The whole exponent is x. Y.
Yeah, it's a whole exponent. Yes.
Yeah.
Okay, so we cannot split this one. Okay, this cannot split. So let's actually evaluate this integral. Yeah. And another reason why we cannot split, because this bound is not a number. So you can split because they depend on each other. You only can split functions if your bounds are going to be number for this function. Okay, so let's evaluate this one. So what I will get? So what is my first integral? My integral is from 1 to 8. So what is the integral of this function?
The x, y to the negative 1/3 over y to the negative 1/3.
Yeah. So we have 1 over y to the negative 1/3, e to the x, y to the negative 1/3, and the whole thing is from 0. 1 second.
Wait, don't you multiply by x to the denominator? It's like you're treating it as a constant.
What?
Should x be in the denominator? So x y to the 1 over x y to the negative 1/3 now.
Give me a second. So we're doing dx dy. I'm integrating this one, yes? So you're saying like,
do the x,
yeah. So, and we treat y as a constant. Okay, so everything is okay. From 0 to cube of y, dy. Thumbs up, you got this? Okay. Y I got like kind of stuck. I have 0 over here, and I have y in denominator. But y is not a problem. Yeah, so it's just 1 to 1/3, so I have y to 1/3. Okay? So after I'm going to evaluate this integral, what I will get? Not evaluate, after I'm going to plug in my bounds. Joey, would you like to have an answer?
Oh, it's just y to the 1/3.
Yeah, it's just 1 to 1/3. We're gonna have integral from 1 to 8. When we're gonna plug in upper bound, exponent gonna get 0. Exponent in e gonna get 0. So, and here's y 1/3, but the 0 will kill. No, 1 second. Okay, so let's not do this. Let's just plug it in. Like, never try to do more than 2 steps in your head because you definitely gonna do mistakes. So let's just do it. So I have e to the x, then it's y 1/3 times y minus 1/3 minus y 1/3, yes, times e to the 0 times y minus 1/3 dy. Yeah. So what I have? This thing is 1. What about this thing? 1. So it's 0. Okay. I hope that I got this problem right, but it's a good answer. Well, because it's a tricky answer. You will get the 0 and you will do a midterm like, what is going on? Like, why I got 0? But don't be scared of 0. So.
Isn't the first one e?
I don't know.
It's y to the 1/3 times e.
Yeah, y to 1/3 times e for the first check.
What's the first one?
First
Let's
check,
see.
e to the 1. Yeah, because it's y, it's cubed.
Oh yeah, e to the 1. Yeah, okay. So this here like mistake. Okay. This e. Okay, then it's not 0. Okay. Then we have this one. Because it's e to the 1. Right? Okay, e to the 1, yes. So it's times e minus y 1/3 dy. Okay, so it's not 0. And this integral you can compute just by taking, so it's equal to y is 4 over 3 over 4 over 3 e minus 1 and from 1 to 8. Because you factor y 1/3 and you just find the integral. Okay. Okay, thumbs up if you got this. Do you have any questions about this problem? Okay, so let me give you a problem from the book just for practice. So please evaluate this integral. So we have integral from 0 to 1. Second one from x squared to 1. Square root of y sine y dy dx. Okay, so let's do this problem. So first I need to find this region, yes? Okay, my integral is big, so let's make it smaller. So from 0, from x squared. So this is my xy plane. And then I'm analyzing my x. My x changes from 0 to 1. So x changes from 0 to 1. Then my y, I'm going to draw an arrow in positive y direction. So I can see the first intersect x squared. But I want to know where it ends. It ends when x equals to 1, yes? So when x equals to 1, I have this point 1, 1. So I have this x squared, so this is my first region that I intersect. And what is my last region that I intersect? Y equals 1. So this is my original region. Thumbs up if you got the same. Okay. And then when I'm switching the order, what do I want to write down over here? I want to write down the same function, square root of y, sine y, dx dy. Yes. And right now I'm looking for boundaries, for number boundaries for y-axis. And for y-axis I have from 0 to 1. And what do I have for x-axis? So what is my bounds for dx? 0 to root y, yes. And why are we doing this? Because right now, this integral in terms of x. So this y is a constant. So after you're going to evaluate this integral, you'll get the integral from 0 to 1. Then you have x times square root of y sine y from 0 to square root of y. Yes? And from here, and this is dy, from here you will get that you will have y sine y minus 0, so you have integral from 0 to 1, y sine y dy. Okay. Do you want me to remind you what is integration by parts? Are you okay? Okay, thumbs up if you want me to move on. Okay. So we skip integration by parts. Did anyone get the answer? What? Negative cosine.
Sine 1 minus cosine 1.
Sine 1 minus cosine 1?
Yeah.
Okay, let's just put this number here and see, I don't know. And please do computation and double check if you got something the same and different, okay? Okay, so Dick? Okay, so do you have any questions about this problem? Okay, so let's move on to the 1b. In 1b, you need to do triple integral. Okay, so what is my 1b? So I will need to start to think about this problem. So you have the triple integral over region E of function E minus x squared plus y squared plus z squared to the power 3 over 2 dv. And I need to tell you what is the region E. And the region E is described by this equation. It's x, y, z points in space such that z squared less or equal x squared plus y squared and less or equal than 1 minus z squared. So first try to think about this problem on your own, and then we're going to discuss it. So you can see that first problem on the midterm basically focus on double integral and triple integral. So you're going to have one double integral and one triple integral for sure. Okay, so let's do this problem. So first, you see this integral. Professor, for the first part 1a and 1b, he gave you hints. I didn't give you hints because I want you to recognize how to do problems without hints. So for this problem, do you want to use what type of coordinates? How do you want to use this integral?
Spherical.
Spherical. You want to use spherical. Okay, so first equals, we want to use spherical. And why spherical? Because we have, once we want to draw a region, we're going to see that it's going to be a sphere and z squared plus, and the cone. And sphere and the cone are described really easily in spherical coordinates. Okay, so let's find this region first, because, let's find this region first. So we have, how we can guess what surfaces do we have, what do we need to do with these inequalities. I have two inequalities, yes. So I'm taking like my first function, second function, and I'm gonna set them equal to each other. So what I will get? I will get z squared equals x squared plus y squared. Okay. For the second one, what I will get? For the second one and third one.
X squared plus y squared.
Yeah. So we'll have x squared plus y squared plus z squared equals to 1. So every time when you see these inequalities, don't be scared to just write them set equal to each other. And after this, what is the name of this surface? This one? Yeah. So right now we have a sphere. And we have a cone. Okay, but here let's be careful. We don't have any bounds for, can z be negative? Yes. Why can z be negative? It's squared. So usually I was giving you problems when you have cone on the upper half. You have cone upper half if you're giving your cone in this equation. Do you see? Because z, here you have that z is bigger or equal than 0. But in this description of the region, you don't have square root. So it means you have cone both directions. And this was the first trick about this problem. So we have cones in both directions. Do we have a color? Okay, so we have okay, thumbs up regardless. So right now, how many regions do you have inside my sphere? I have 2, and I need to choose the right one. So we have region bounded by cone and region bounded outside of cone. So who thinks it's region bounded by cones? Who thinks region bounded outside of the cone? Okay. When I was walking through in the class, I was telling you how you can check which region do you want to choose. So how we can choose the region? How we can choose the region, the right region?
So like log in coordinates.
What?
Log in the values of x, y.
Yeah. So we need to choose a point here. So for example, if you will choose this point, what is the coordinates of this point?
0, 0, 1.
0, 0, 1. And after when I have the coordinates of the point, what can I do with this coordinate? How I can check if this is the right region or not? I can plug it in, it's over here. So I have 1 less than 0, so it's incorrect, yes. But if you will choose this point, for example, 1, 0, 0, then you will have 0 less or equal than 1, less or equal than 1. So it means if you want to integrate, you want to integrate over this region. Okay. So do you have any questions about how I found my region? Maybe do you have? How many people got the right region right away? So did you miss a part about double cone? Yes. Okay. So this was the trick about this problem. So make sure. Yeah.
So can I explain how you got the double cone again?
Okay. So I got the double cone because I have this inequalities, and this inequalities means I need to choose some part of the region in 3D.
Right.
But if you want to choose some part of the region in 3D, you need to find the bound. Yes. And here I have two bounds. I have this bound and this bound. This bound is a cone. And when you find the equation of this cone, your equation is not written like as z equals square root. Equation of the cone, like as you know, like this, it's actually like a cone. Okay?
Are the walls of are like the
Straight lines.
yeah, okay. And are they just steeper than if you had z equals?
Yeah. One thing that it's good that professor skips some surfaces because he's not going to give you hard ones. He's going to give you only cones, paraboloids, and spheres. Okay? So, any other questions about how I found this region? Kyle, do you have any questions? Okay. So let's right now change our integral. So we have the triple integral. So what happened with my function? What? Yeah, it's going to be e, instead of x, y, z, I'm going to plug in spherical coordinates. And x squared plus y squared plus z squared equals to what?
Rho squared.
Yeah, rho squared. But then I have rho squared to the power 3/2. So I have just rho cubed. So I have triple integral of negative of to the power negative rho cubed. And then what I'm doing with my dv? I need to expand my dv. Yeah, and please make sure that every time when you change your coordinates or expand your dv, you don't forget about Jacobian. Sine phi, and then I have d rho, d phi, d theta. Okay? Thumbs up, you got this? Okay. And right now let's find bounds. So let's describe this region in terms of rho, theta, and phi. So which angle is the most easiest to describe?
Theta.
Theta. So what is bounds for theta? What bounds for phi? What?
Pi over 4 to 3 pi.
Yeah, pi over 4 to 3 pi over 4, because my angle phi is angle which makes this red vector between positive z-axis direction. Yes? And Anurag, how do you know that I have pi over 4 to 3 pi over 4? What do you do?
So the way I did it was looking at the cone equation, I changed those to spherical coordinates. So essentially what I did was I turned z squared into rho squared cosine squared phi equal to rho squared sine squared phi.
Okay, this is good. Yeah, but there is a faster way how we can figure out like what is the angles, just based on the picture. So how we can do this? Matthew, do you remember? Kyle, do you remember? Get out your phone. What?
R squared, like R is equal to C or negative C, so it's like
Yeah.
can get pi over 4.
Yeah, so let's take a look at this cone. Yes? And let's project this cone into YZ plane. when I project this cone into YZ plane, what I will get? Let's do this. If I have my cone, I will project my cone into YZ plane, what I will get? I'm going to get 2 lines, yes. And what is the equation of those lines? Yeah, it's going to be z equals y and z equals minus y. Yes? And how we got that z equals y, Carl? What? Integral? Okay. Joey, how we got z equals y?
Because we set x equals 0.
X equals to 0, yes. And right now, basically, this picture, this is my sphere. So for what region I'm looking? I'm looking for this region, yes? But what do you know about this angle?
Thank you.
Yeah, see, it's pi over 4. And what do you know about this angle? 3 pi over 4. That's it. So we have from pi over 4 to 3 pi over 4. Okay, and the most easiest one was our row? From 0 to 1. Anurag, can you explain why it's from 0 to 1?
Looking at the last equation, x squared plus y squared plus z squared is equal to rho squared.
Yeah, we plug in this row and we can see that row changes from 0 to 1. Because we go from like 0 origin and outside to the boundary of the sphere. Okay, thumbs up, you got it? Okay. So let me erase final region. I'm going to show you a couple of steps of evaluation of these integrals, and then, so what can I do with this integral? How I can, there's one really simple integral that I can write answer right away. Theta. There is no theta inside, so you can just write 2 pi right away. Do you see why? Then, what can I do with the rest of this double integral? I can split it right now because my bounds are numbers. So I have integral from pi over 4 to 3 pi over 4 of sine phi d phi. Yes? And times what? Times integrals from 0 to 1. Yeah. Rho squared e to the negative rho cube 0. How do you do this integral? Just cosine theta and negative cosine theta. And do you remember this cosine of pi over 4? Right, 2 over 2. And what is cosine of 3 pi over 4? Negative?
No.
It's positive. So I think actually this integral is going to be 0. Maybe, yeah. I don't know. Did anyone solve this integral completely?
It's not 0.
It's not 0?
I think 2.4 is negative.
It's negative? Oh, then it's not 0, yeah, okay. I mean, like, yeah, I'm going to raise this integral, so, and I know we have negative cosine phi, and our bounds from pi over 4 to 3 pi over 4, yes? No, power, 1 second, not 3 pi over 4. Pi over 4 plus pi over 2. Yes? So it's going to be, no, it's going to be 3 pi over 4. 3 pi over 4. And what is my cosine? My cosine, there's 2 ways how we can figure out if you forget. Cosine function looks like this. So it's 1, this pi over 2. Yeah, so your cosine function goes like this. So we can see when I have pi over 4, my cosine is positive. When I have 3 pi over 4, my cosine is negative. So it's not going to be equal. Okay? And what about this integral? How do you evaluate this integral? U sub. And what is my u? Negative rho cube. Yes. Yeah, okay. Thumbs up, you got this? So here is just computation. So this problem we're done. Do you have any questions about this problem?
What, Matt?
Yeah.
We evaluated, should it be 0? Because sine 5 is like symmetric. It's like an odd function with pi over 2. Right?
Yeah, but you count symmetry to the if it's symmetry. If your bounds of your integration symmetric corresponding to the origin, but here's a non corresponding to the origin.
But like the sine function is odd with pi over 2.
Here, okay, so let's move this minus over here. Yes.
Yeah.
Then I have cosine 3 pi over 4. It's going to be negative root 2 over 2. And then I have minus root 2 over 2. So I'm going to have just minus root 2. Okay?
Yeah.
Okay. So this is the thing that will equal minus root 2. Other questions? So let me erase this. Can you tell me, have you done practice meter number 1 and 2? Or like problems for integration, double and triple integrals in the same style? Yeah. Did you have like spherical coordinates or cylindrical coordinates for cylindrical? We can check later. I mean, like for problem number 2, for problem number 1, you can see for sure you're gonna have one double and one triple integral. So make sure you know how to do it. Okay, let's do problem number 5. Just to remind ourselves. Okay, so for problem number 5, you have a parametric curve R of t equals to 1 half t squared, 1 over 3 t cubed, and t changes from 0 to 1. So find the length of this curve. So let's do this problem. So if I want to find the arc length, do you remember the formulas they need to use? What?
Dot product with the RT dot product with R dash T.
1 half.
Yeah.
Yeah. So it's going to be the integral. In this case, my bounds from 0 to 1. Yes. And one of the way to remember this is just square root of x prime of t squared plus y prime t squared plus z prime of t squared dt. Okay. When x, y, z are components of your r of t. So what is my r prime of t equals to?
0.
Yeah, it's going to be 0, t, and t squared, yes? So then this my integral going to be equals to integral from 0 to 1. What do you have under square root? I have t squared plus 2t to the 4 dt. Then how can I simplify this integral? Yeah, I can factor t squared. So I will have integral from 0 to 1 of t square root of 1 plus t squared dt. And next, what I'm doing? I'm doing u sub. So here my u equals 1 plus t squared. So my du equals to 2t dt. So what should I do with my integral? How I should rewrite it? First, yes, we need to check our bounds because we change our variable. So our bounds in terms of t from 0 to 1, but my bounds in terms of u, when t equals to 0, u equals to 1. When t equals to 1, u equals to 2. Yes. So I have integral from 1 to 2. Okay, what else? What do you want to write down over here? Yeah, because I have t dt and t dt equals 1/2 du, so I have 1/2 du. And what goes over here? U 1/2, yes. Then this stuff is equals to 1/2 U 3/2 over 3/2 and changes from 1 to 2. And here 2 got cancelled. So you can just plug in your numbers and you will get your final answer. Okay, any questions about this problem? Okay, I just want you to remind how to do finding the arc length. Okay, so can I erase this? So let's do the next problem. As the next problem, finding the absolute maximum and absolute minimum. And problem about vector fields, I'm going to give you as a worksheet problem, and we're going to do it in class because if you're going to do it now with this graphing, it will take us a lot of time, and I want to do the problem in groups. And let's do problem number 3. Find the absolute maximum and absolute minimum. Okay, so we're given the function f of xy equals to x squared plus y squared plus x squared y plus 4. And we're given our set D. It's all points in xy plane when x changes from 0 to 1 and y changes from 0 to 1. So what do I want to do? I want to find the absolute maximum and minimum for this function. It's a good problem. Yeah, so see, you plug in this one. Yeah, because we're negative power, positive power. Okay, so let's discuss this problem. So, how is absolute maximum and minimum different from local absolute maximum and minimum? So, for this problem, what do you want to do?
Let's find a critical point and check if the critical point lies between the region.
Yeah. So let's kind of thank God we have really simple region. Yeah. So let's draw this region. So if you see something simple and you're doing this midterm, do something simple. Yeah. So what is the region? The region from 0 to 1. We have this region. And right now let's analyze what do you want to do. So first step, we want to find the absolute maximum minimum. Yes. On this region. So it means here we need to do two things. First, we need to find local absolute maximum minimum. So you need to find the critical points as a function. Some critical points might be inside, some critical points going to be outside. So what do you do with critical points at outside? You throw them away. Yes. So this is step 1. And for step 2, what do you need to check? What do you need to do? I need to find along the edges. So let's do it. So for step 1, let's find absolute maximum minimum, like local max and min inside the region. Yes. So let's find our local max and min inside the region. Okay. Do you have any questions about this problem? No. Okay. So inside the region, what do you need to do? You just need to find like a critical points, yes? And critical points, my f of x equals to 0 and f of y equals to 0. So what is my f of x? My f of x is 2x plus 2xy equals to 0. And my f of y is 2y plus x squared equals to 0. So what I'm doing over here next? From what equation for me is going to be easier to get my critical points? From the first one. Yes. First I can cancel out 2 because I can just divide by 2. And then I can factor x. And when I factor x, I will have x 1 plus y equals to 0. So what I'm doing next? I'm separating the first equation into two choices. What are my two choices?
X equals 0.
X equals 0 and
Y equals
y equals -1. Yes. When x equals 0, what I'm doing next?
Substituting X equals 0.
Into this equation. When x equals to 0, I will get y equals 0. So what I get? I get the first critical points 0, 0. Okay, what I'm doing with my next option? The same. I'm gonna plug it in over here, so we'll get x squared equals to 2. So from here we'll get that x equals plus minus square root of 2, yes? So how many critical points do I have? 3. So my critical points, you can write it down here, is going to be 0, 0, and plus minus square root of 2 and 0. But how many critical points do I actually need? 1. Because 0, 0 is here, yes, it's my 0, 0. And square root of 2, 0 is going to be outside of the region, and negative square root also outside of the region. That's why we need only 1 point. Okay, thumbs up regardless. So step 1, we keep doing. So what do we need to do with this point right now? Yeah, we need to find this like maximum, minimum, or saddle. So for this one, what is my f of x? It's gonna be, I erased my f of x.
It's going to be
2y? Okay. What is my f of xy?
2.
It's gonna be if y 2y x squared.
Is it f of x?
It's 2x.
2x.
Plus
What?
2x.
F of x.
It's 2 plus 2y.
F of x 2 plus, okay. Like this? Okay. And then what is my f of y? It's 2y plus x squared, so it's just 2. Yes? Yeah. Okay. And then if I know that my point is 0, 0, what am I doing with that point 0, 0? Plug it in, yes. So, because I have just 1 point, so I can see that my f of x equals to 2, f of xy equals to 0, f of y equals to 2. So what is my d? My d is f of x times f of y minus f of xy. So it's 4. So it's 2 times 2 bigger than 0. So do I have mean or max? Why I have mean?
Because
First, my d bigger than 0. So I have either mean or max. So how do I decide which one do I have? F of y is or f of x is bigger than 0. So it means that I have its concave opposite, so I have mean. So 0, 0 gives me mean. And what is the value of this function at this point? 4. Yeah. Okay. Do you have any questions about step 1? Okay, thumbs up regardless. Okay, so next thing for step 2, we need to check bounds. Can anyone tell me what should I do if I want to check this bounds?
plug it back.
Yeah, I have, like we did Jacobian, I have 4 equations for bounds, yes. And I know, by what equation can I describe this bound, for example? X equals 1. What about this bound? What about this bound? What about this bound? Y equals 0. So right now in my first step 2 I have y equals 0, x equals 0, x equals 1, y equals 1. Yes? But when y equals 0, what is my function equals to? My f of x, 0, equals x squared plus 4. And then what I'm doing?
Checking the min and max with respect to school.
Yeah, because this function is single variable calculus, min or max. And you can check what is your f prime? What is your critical points? It's 0. And you will get, this is concave up, you will get exactly that this is your max. Okay, thumbs up regardless. What about when x equals to 0? What is your function? So, can you tell me answer right away? The same thing, yes. So, for both of these bounds, check and check, we have the same this critical point. Yes. But let's do next one, let's do x equals to 1. So when x equals to 1, what is my function equals to?
5.
Yeah, I will have y squared plus y equals to 5. Yes? So, what is my f prime?
2y plus 1.
Yeah, it's going to be 2y plus 1. So what is my critical point? Negative 1/2, but it doesn't lie on my... No, so there is no. And let's check y equals negative 1. Oh, sorry, y equals to 1. So when y equals to 1, what I have? I have f of x1 equals x squared plus x squared plus 5. Yes? So what is my critical point? What? Give me a second. So I plug in y equals to 1, yes? So it's going to be 1. So what do you say? 0, 1? Okay, yeah. F prime of x is going to be 4x, so it's going to be 0, yes? Okay. And 0, 1, x equals to 0 is this one, yes? And y equals to 1 is this one. Okay, so this is critical point, yes. Yeah. So in this case, what is my value? What is my value? So is this minimum or maximum? It's maximum. Yeah. So I have this point 0, 1 because my f prime of x1 equals 4x equals to 0. So my critical points x equals 0, but I know y equals 1. And this function is concave up. So this point on this bound is minimum, yes, but this point on the whole region is maximum. Because what is the value of f of 0 and 1? What is it equals to?
5.
It equals to 5.
It's the absolute value maximum 1, 1
What?
for the entire region.
1, 1?
Yeah, because I could use that. Yes, that.
Ah, yeah, you can just plug in this boundary points, yes. Yeah. So here, okay, so let's just finish this one. So first we found this one critical point, f0, 1, yes. So what we did, we check our critical points on the whole like lines, but lines intersect. And in this intersection you have like this boundary points. And you cannot detect these boundary points as critical points. So what we need to do for this point 1, 1, 1, 0, you need to plug it in this back here. Do you see? Do you understand why? Again, because when you're looking for the critical points on y equals 1, you can only detect like one point. But you also have this corner point, which is not critical point, but each one you need to plug it in. So that was, what is my f of 1, 1? Is 1 plus 1 plus 1 is 6, 7. And what is f of 0, 1, of 1, 0? It's 1, it's also 5. Yes? So what do I get? I get like this point is absolute maximum. and this point is absolute minimum.
The max, we can we can just say because the function is always increasing, like 0, 0 will be the min and 1, 1 will be the max.
Yes, but you will get points off for this, I feel.
Oh, because we don't show.
Because you're just saying well, the function is increasing, but it's not the proof. Like there's computations that needs to be done.
Okay.
And the argument that I feel is like how we should argue, because when you're looking for the critical points on the whole, when you plug in y equals to 1, you're looking for the critical points in the whole line. But if you're looking for critical points on this line and this line, they intersect at this point. So you also need to check this point for the value. Okay.
So when we like checking the lines, why can't we find the point 1, 1?
Because when we either check this line or this line, this 1, 1 is not going to be a critical point for x equals to 1 or for y equals to 1. Yes.
So essentially, you have to check those individual points
Yeah.
separately, right?
Yeah.
So first find the critical points, then check your boundary, and then your boundary.
Yeah. I finally understand this problem. You're like, why? The best way to see if you understand something, try to explain to other people. And finally understand like why we need to check boundaries, because you have this critical, you're checking this critical point, checking this critical points, but this is also like intersection. So you also need to check this boundary point.
Got it.
Yeah. Cool. Do you have any other questions? Okay, so for today we are done. If you have any other questions, let me know. Just shoot me an email. On Monday, we're gonna cover fundamental theorem of line integrals and Green's theorem, and I'm gonna have office hours on Monday, so please stop by, ask me about like triple integrals. And on Wednesday, there's gonna be no quiz. And on Wednesday, we're gonna do kind of review session.